Now let's talk about a capacitor. What's happening in a capacitor? I have explained in last video that in a capacitor, the main duty of a capacitor is to block DC. That is, DC means direct current. When a current passes from left to right and when it hits the first plate, charges will accumulate in the first plate. That is, it is having only one way direction, right? When a DC current is coming through, the positive charges will be accumulating or the negative charges will be accumulating in one plate, and in the other plate the other charge will be accumulated, just like this. So what happens is a voltage is developed across these plates. That development of voltage only occurs after an incoming of current. When a direct current flows, only after the development of this direct current, that is the voltage, starts to develop across these plates. So how can we say that the current will come first, or the arrival of the current will be the first, and only after that the voltage will start to follow it. So we can say that the voltage across a capacitor will follow current, or in other words, voltage lags current in a capacitor, or current leads voltage in a capacitor. Next, I am going to take a simple circuit that is containing an AC source and a capacitor. So Vm sin theta is the supply source, and let the voltage which will be developed across the capacitor, let it be V. Okay, and the current that is passing through the capacitor, let it be I. So I am going to have a comparison between voltage and current. Let us check out, or let us put this sentence into a graph. So we can have two representation. As I've said, there are two representation. One is the graphical representation and another is the phasor representation. So we are going to compare the magnitude of the voltage and current, and also the what is the angular shift, what is the phase lag. See, I have explained while describing the inductor, I have explained that it is similar to a running race between two guys, isn't it? One will start at 9 a.m. See, one will start at 9 a.m. and another will follow him at 9:05 a.m. So when there is a starting difference or a time lag between two guys, there will be definitely a displacement shift also, isn't it? Similarly, in the case of capacitor, there is a time delay between the development of current and voltage, isn't it? So definitely there will be a phase shift happening between the voltage and current. And there is a statement that for a purely capacitive circuit, current leads voltage by 90 degree. Okay, so let's put everything into a graph. Again, we are going to compare the voltage and current that is developed across a capacitor. Okay, with respect to its time. So when there is, and since there is a time lag, I can say that there will be a phase lag also. So I am going to compare or I am going to draw the voltage and current with respect to theta, and never gets confused that we are applying an AC signal and DC is getting stored here, because AC has two cycles, isn't it? One positive half cycle and another negative half cycle. So at first time positive will be accumulating in the first plate, and alternatively in the next cycle negative will be appearing here. So let's see. Since Vm sin theta is directly given to the capacitor, I can say that the complete source voltage will be appearing across the capacitor. So the voltage graph will be another sine wave, just like that we drew for an inductive circuit. Okay, and here is 180 degree, this is 360, and we have to mark this 90 degree, isn't it? So the half of 180 will be 90. Now, how to draw the current wave? Current leads voltage by 90 degree. That is, see, this is 190 degree and this is also 190 degree. That means the development of current will already have occurred before the voltage itself. That is, here the voltage has obtained its maximum value at 90 degree position. But the current would have already obtained its maximum before this 90 degree phase shift. That is, at the 0th point itself, the current will have gained its maximum. At this point itself, the current would have started to raise to its maximum. So the current signal will be like, and the maximum of current need not be this height of voltage itself. So let us mark this as Im, and the maximum for voltage, let it be Vm. So it is very clear that the current has reached its peak at 0th angle, but the voltage has only reached its maximum 90-degree phase after this current has reached its maximum. Hence, current leads the voltage by 90 degree. And let's see the phasor representation for the same. We know that the vectors are moving in an anti-clockwise direction, and we have two vectors, voltage vector and the current vector, and the current vectors is moving faster, isn't it? Since it is having an anti-clockwise rotation, we can say that the current has already reached here, making the voltage vector way behind it. So the current leads the voltage by 90 degree, and if the voltage vector when takes a 90 degree shift, the current will have already reached here, and thus the voltage vectors go through. And generally we can say when the voltage vector is here, see, always the reference vector is the voltage vector and the reference point will be towards right. That is, this is usually taken as the 0 degree. So when the voltage is here, the current would have already taken a 90 degree path ahead. So this is the phasor representation of voltage and current for a capacitor.